But again, we're looking at a calculator-based approach, so keep that in mind. Find the point of intersection. I mean, that you may want to do algebraically, or maybe on the calculator, depending on strengths and weaknesses. You're looking for a dominant function. Right? Dominant, we define as being above or to the right. Right. So if one graph is physically above another, or if you're looking at something that is implicit, you know, kind of like what we just did, it would have to be something like on an interval, something like that, and then you'd have another graph that's to the right of it, right? So to the left of it. So we're calling these two guys here are considered to be the dominant ones because they're either physically above or to the right of another function, right? Once you have that information, it's pretty easy to come up with everything else, right? So if you're doing some integration, but it's the integration of the difference between the dominant and the non-dominant function. One thing you got to keep in mind is that dominance could change over an interval. All right, that's why we find the intersection. Because if there is an intersection between two functions, there's potentially a location in which one function ceases to be above another and then starts to be below, right? Unless it's kind of a cusp, you know, like you would have for a fractional exponent. So let's take a look at example 1 here. Find the area of the region bounded between these two equations. All right. You pop it in the calculator to get a sense. And again, it's kind of the moral of the story here, so well, I keep hitting the wrong thing. All right, so we have our two equations in. We know we have a little bit of an issue here, just in terms of domain and range, even. This is pretty big, and it's increasing. So when I come up with my window, I mean, you can do a zoom 6 if you want, but a lot of it's happening off the grid. You want to have a pretty tall Y max, so maybe like 100.
You do that thing you showed us also, right?
You could, yeah. So just a quick review of that, because again, we don't always know stuff is important until it smacks us in the face. So I'll just do a zoom 6. You have your graph. Yeah, so if you didn't know where that 100 was coming from, then this is for you. So you need to know what your domain is. This domain looks perfectly fine because it covers the important parts of the parabola, but maybe it's not wide enough, I don't know. But I'll start with it. So x min, -10, x max, +10. Then go to y min, hit clear, then zoom 0. Look at that. They said it should have been 117. I said 100. We're both fine, I think, because 117 will bring it like down to here. Either way, perfectly reasonable. Right, so zoom fitting the y min or max. Doesn't matter which one you zoom fit. All right, so I need intersections, right? Because here I'm looking for the area bounded between. Well, it's pretty clear that the line is the dominant function. That's the one that's physically above the parabola. Here is the equation of a line. Here is the equation of a parabola. So I'm looking for the difference between those y values. 4x plus 45 minus the other guy, in parentheses, x squared plus 2x minus 3. I'm going to integrate that with respect to x. It's just a question of from where to where. That's where the intersection comes into play. Because I need to know what this guy, oh, I'm about to put my arrow the wrong way. What this one is, and also what this one is. And if I can find those intersections, I'm going to be in good shape. 2 ways to do it. 10 ways to do it, but I'll only show you 2 ways. One would be to use the intersection function on your calculator. The other would be to use the quadratic formula, because if we're going to have the intersection between 2 functions, it's going to happen when those 2 functions are equal to one another. So if I pull them off on the side, I could say x squared plus 2x minus 3 is equal to 4x plus 45. Quadratic formula, completing the square, quadratic techniques is what I meant to say. I don't want to just limit it to quadratic formula. However, I do have a quadratic formula program, so maybe I do want to limit it to quadratic formula. So I have to do a little background work, but it's not the end of the world. Quit out of here. Program quadratic formula. 1, negative 2, negative 48. So negative 6 and 8. Oh, that's nice. I'm doing algebra without doing algebra. Negative 6 and 8. So now I know my boundaries of integration. Negative 6 and 8. So I can go into my calculator. Now I have these stored in as y2 and y1. So I can actually type into my calculator negative 6 to 8 y2 minus y1 dx. For quality 1. But this will look a little bit better. So you could do math 9, or you can do our newfangled alpha window option 4. Gets you the same place. And then, meh. Oh, that looks awful. A math bracket if you want. But again, I'm more interested in the integral here. And again, just like the couple pages ago, a question could say write an integral or a sum of integrals that could be used to find the area of a region. Because I don't know that I'm overly concerned on more than 1 or 2 instances during a test on your ability to tap your calculator several times and hit enter. So it's what you are typing into that calculator throughout that process. That's what's more concerning, right? So, or I am more concerned with. We'll get to the algebra. Unit 2 is, like when people say Calc 2 is hard, they're talking about Unit 2, right? So enjoy Unit 1 while it lasts. Between the Correct. Then you'd have to be given a restricted domain. Otherwise, it's infinite. It's a smaller infinity than some infinities that are out there, but it's still an infinity. That's a good question.